Carbon fiber wheels, the ultimate upgrade. They make any bike look cooler and faster. But wait, these aren't made from carbon fiber. Oh no, carbon fiber's so naughties. These are made from the future, fusion fiber, by a company called Forge and Bond, who are based here in Utah. Fusion fiber has a number of key advantages over traditional carbon fiber. I'm going to go in their factory and I'm going to explain why. Using their new fusion fiber process and greater automation has allowed Forge and Bond to manufacture their wheels here in the US, compared with traditional layup techniques which, owing to the high labor cost, forced manufacturers to Asia. Forge and Bond's parent company do still use traditional carbon techniques at this Utah facility, but for the premium aerospace sector. This new process is really fascinating, and it has a number of key advantages over the traditional layup techniques you may have seen before. But to fully appreciate that, let's just have a quick refresh of the established techniques. Carbon fiber is a composite material. Composites are great because they combine the different material properties of different materials together to make a super material. Now, in the case of carbon fiber, you've got fibers of carbon, and then they're surrounded and bound together by a matrix of epoxy resin. Reinforced concrete is also a composite material. You have fibers of, well, steel rods surrounded by a matrix of cement. The traditional technique uses pre-preg carbon. That's sheets of carbon fiber that has been pre-impregnated with an epoxy resin. The disadvantage with this kind of material is that it needs to be kept frozen, otherwise it goes off. So when it's being transported to the factory, it needs to be kept frozen, and then it needs to be kept frozen once it's here too. And that requires a lot of energy and also planning on how and when you use it, because it has a sell-by date. The first step of manufacturing involves taking the big sheets and rolls of pre-preg carbon and putting them onto profilers, where they then get CNC cut out into the swatches that are required for whatever is going to be laid up, whether that's wheels, frames, or whatever other component you're building. The CNC machines are designed to maximize the material and cut out as many shapes on it as they can, but you do inevitably get some waste, and that is another disadvantage to this traditional process, because the waste offcuts that you get, this bin is full of them, can't really be recycled. The cut swatches of pre-preg are then assembled by hand into molds. Now, this is super labor intensive, and you also have to be really careful not to get air gaps between the layers, because that will result in voids. After a carbon fiber component has been laid up, it then needs to be baked and cured. And so they do that in big ovens called autoclaves. Now, I've been in some autoclaves, well, I've seen some autoclaves in the past that are much smaller. They're like industrial ovens, and you just put your frames and your wheels in. This one is ginormous, and that's because here they're not just manufacturing sort of bike components, they're doing a lot of aerospace and defense stuff. So for satellites, helicopters, planes, that kind of thing. And I mean, this thing's massive. It can go up to 450 degrees Fahrenheit and over 100 PSI. You wouldn't want to get stuck in here when it gets turned on. But it's also, it uses a huge amount of energy, this process. Ooh, look at the size of the door. After a carbon fiber component has been molded and cured, the last step is just the surface finishing of it. So this is actually a piece of wing. It's not a bike wheel, but you can see as it's come out of the mold, it's got a lot of material on the edge here that's not required, and this needs to be trimmed off. One of the downsides of the traditional technique is this material that gets trimmed off is just waste. It just goes in the bin, can't be used, can't be recycled. It's not just bike wheels that they're making here, though. That's just one offshoot of the business. Their core business actually revolves around aerospace, and this is actually part other satellite. In about 4 months' time, this will be in space. And, well, making bike wheels is kind of pretty easy compared to, this kind of stuff. The crazy thing about this as well is, bike wheels can be super expensive, but just be grateful that you're not riding a spaceship, because there's 4 parts of this to make it into a cylinder. In total, they're $450,000. So cool, though. So, that was the traditional process of carbon layup. Now, let's take a look at the new way. The key difference is the material that you start with. So, this is carbon fibre, but instead of an epoxy matrix that we had in the pre-preg, what we've now got is nylon. And this results in several different material properties. The first of which is that you don't have to keep it frozen. You can store it at room temperature, which is why we see it on all these boxes just here, which is a huge logistical saving. And the other key difference with this is that nylon is a thermosoftening polymer, which means that this can be heated and then molded and then set and then reheated and remolded multiple times through different heating cycles, whereas the epoxy resin that's in traditional pre-preg is thermosetting, which means that once it's cured and you've set it into a shape, that's it. It's delivered from Torre, who is a name you will be familiar with. They make a lot of carbon fibre. It comes in these rolls, which is what they use when they're manufacturing the wheels. They put it on these big spools and they take it onto this big, massive machine here, which is then going to feed it and cut it into the requisite pieces. So this gigantic machine feeds this giant tape of carbon into it. It's like a giant Walkman, if you ever had a cassette Walkman. That's what it reminds me of. And then it comes in here, and then it pulls it through and cuts it precisely into the required shapes that we're going to use in the layup process. It's able to do this with a lot of speed and incredible precision. And then what you have is this kind of inverse air hockey table that sucks it down so that it's held firmly in place and it's not moving around. There are actually 132 different swatches of carbon that go into one half of the wheel. It then places them on this giant turntable with a huge amount of precision. And then this is the really cool bit. Inside here, the machine is able to ultrasonically tack weld those pieces together so that they're all in the right place, and then they can be lifted up to the next step. But doing it in this way, this machine is really, really quick and it's really, really precise. It's got a tolerance of 0.1 millimeters, so it's far more accurate than a traditional layup technique using a human. Yep, the robots are coming for us. So why isn't this material and these kind of techniques used more widely in the bike industry? Why haven't we seen it before? Well, there are several hurdles that you need to overcome. Making wheels out of this kind of material requires a complete rethink of how we've done things in the past. And there are several big hurdles, including, if you look at the big machines behind me, they ain't cheap, but also working out how best to use these machines in order to make this material play ball and get the end result you want also isn't straightforward. But the guys here, they seem to have cracked it. So the next step is to take this over to this machine, which is called the Fibercon. Sounds like the world's lamest Decepticon. It's actually pretty cool. So the Fibercon is a really cool piece of kit. It heats these sort of pre-arranged swatches of carbon together, and this is what actually creates the fusion fibre, because it is melting the nylon and allowing it to flow through all the fibres and then bond it all together. This machine is able to spin round and then actually cool this piece as well once it's been bonded together, so that it can be taken out. It's really efficient because it can do this process in a few minutes. Whereas if you were to do this in an autoclave, that would take far longer to do. It's far less efficient. But it's not just that. Having this machine laid up essentially by a robot isn't just more accurate, it's also far quicker. Laying up 132 swatches, if you've got both wheels, it's 132 on both sides of the wheel. that would take hours and hours and hours for a human to do that. So this is how it comes out of the fibre, Con. It's been subject to a lot of heat and pressure, and then it's been cooled, so it's easy to pick up. It's got a few sharp edges on it, and they will be trimmed off and can be recycled. But this is a 2D half of the wheel rim. So we're going to take it to the next step to make it 3D. The next step is to take our 2D flat wheel and make it 3D. And they use this huge press to forge the carbon. And that's where Forge and Bond gets their name. And the big takeaway from this is that this material allows for multiple heating and cooling cycles because it doesn't thermoset like the epoxy. So we can once again heat it and then forge it into this 3D shape. The excess material is then trimmed off with a high-pressure water jet. Well, you wouldn't want to jet wash your bike with that. Then you have the two halves, and they can then be connected together. These will then be welded together, and there's a few more steps to go. Now, time for the bonding in Forge and Bond. The components of the wheel rim are placed together in a mould, and then an air bladder is placed inside them to give internal pressure. And then the really cool thing about this process is it doesn't require the same surface finishing that many other wheels do. So they've laser etched these moulds with whatever logo you want on there. So there's one on here. And then when this comes out, that's it surface finished. It has the required logo on there as it's been sort of moulded in to the carbon. And so there's no need for painting, lacquering or applying decals as we've seen in the past. That is really cool, really efficient. When the mould is assembled, it's put into this heated press where it's pressurized up to over 100 psi and over 400 degrees Fahrenheit. And then it comes out, it's cooled, the wheel can be taken out, the bladder removed, and then you can see the finished product.
So you might be asking at this point, that sounds great, but why are they still making satellites and jet fighters using pre-preg carbon? Well, the epoxy-based carbon fibre can survive much higher temperatures, over 450 degrees Fahrenheit, something that's kind of critical for spaceships. However, nylon starts to soften around 300 degrees Fahrenheit, so while not suitable in those applications, it is ideal for bike wheels. And in case you were wondering about it melting in the back of your car on a hot day, well, those temperatures don't tend to get above 190 degrees Fahrenheit.
The moulded rim is then placed inside the robo drill, which can then be adjusted with little inserts depending on the size of wheel that's being drilled, and it basically puts in all the spoke holes and valve holes with, well, incredible speed and precision. That's what you got here. I'm just really impressed with the surface finish of how this just comes out after it's been, well, essentially baked. It's just really cool. And the final step, getting the finished drilled rim and then inserting the spokes and building it onto the hub. And then you're good to go. It can be shipped all over the world.
The final key advantage is by having nylon as the matrix gives better vibration dampening in the final composite, which, according to Forge and Bond, makes it very desirable for improving a bike wheel's ride quality.
Now, hopefully you've noticed that I've been mentioning the waste that gets trimmed off at the various stages, because if you cast your mind back to the more traditional carbon layup process that we spoke about at the start of the video, I mentioned that waste is, well, it just becomes waste. You can't really recycle it, and so it's not very good. Whereas here, what they do is they take that waste, they chop it up, and then you can compression mold it into other things. So one of the things they do is compression mold it into tyre levers. I mean, it looks like a tube of toothpaste, but there's tyre levers in here. And that way, nothing goes to waste. You actually get a set of these included when you get some wheels. But it's not just tyre levers, it can be used to make all sorts of different things. So stems, pedal bodies, and just, well, all manner of components. I've loved seeing this process today. It's so cool and interesting to see the innovation that's gone into this. I hope you have too. And Trek clearly rate it. But let us know your comments down below. And if you've enjoyed this video, give it a thumbs up. I'm going to go now. But how nice is Utah?